Okay, good morning. So for anyone who does not have a seat, you probably try to find that there's some empty seats right in the middle of the, like for example, there's a seat there, there are some seats over there in the middle. You probably try to find a seat, you can take a seat. Okay, the class is very full, but we probably try to accommodate everyone. Okay. The first thing is I haven't figured out because I tried the projector. It only projected half of the slides. I'm still trying to reboot the machine. Hopefully it will show the whole slides. Before that, I'll probably say a few things. Okay. First thing is the class is very full. We got this classroom has only 200 seats, which is the largest one in this SIBO center. Okay. So to that extent, we actually can only take, legally, can only take 200 students. The class is very solid book with 200 students, but we still have a pretty large crowd they want to get in. Okay. So the only thing we can do is we are discussing with the department. First thing is this CS412 data mining course is opening every semester. Actually, we even open in the summer. That means we open 3 times a year. If you cannot register this semester, you will have chance to register the next semester. Okay, that's the first thing I should say. But we do have some students that they are going to graduate, or they are PhD student, they need to take a PhD qualification exam, which taking this course is critical, or some other department, they said that this course is prerequisite or is required for some research. Okay. In that sense, I may make some exception in 2 cases. One case is we put anybody who wants to register, I first ask you to sign on the waiting list. Okay. That means you will be in the queue. You are going to state the reason why you have to register this fall instead of next spring. Okay. You have to say it clearly. Okay. So that's the first thing. The second thing is once you registered, the TA and me, we are going to evaluate you to see whether we can make a special case. Special case, what is a special case? One special case is if anybody dropped the course, okay, hopefully in the first two weeks, we will be able to put those students in, okay, on the waiting list. You may have some higher priority if you have a very good reason. Okay. Another thing is we may open a small special session. The session is you can watch video, because this one actually is video recorded. You can watch video, but you cannot come into the class if the class is full. Okay. Of course, if you want to come to the class, there's one thing I probably can do is say any empty seat, some student may a particular day may not attend the class, we may allow you to get in. Okay, so that's the kind of situation. That means if you have very good reason, we finally may put you into the overflow session, okay, not in the regular classroom session. You will be able to do homeworks, you will be able to watch the video, and you are required to take an exam with a class, but you cannot attend a lecture. Okay, so that's the thing. We probably have to make some very special arrangement. But that's alive because we have more students, but we have less room. Okay. So I think we still have some problem. I will try to get the projector on to see what may happen. Okay. Hopefully we will be able to get this because yeah. Yeah. The previous AV only showed half of the slides. I do not know what happened. I tried every way, could not. I rebooted the machine. Okay. You may try to see whether there's any way you can, because it seems the previous class is working. Now you see those small ones can show the whole class. I try to knock the, you see, that still show half. This part, you can see the later half of the picture cannot be shown. I do not know what happened. I think that works. Okay. Okay. So if that's the case, I probably do not need the side one. Do you still need the side one? Probably we don't need it. We just need a bigger one. We probably can take the side off. Let me see. They have a screen control. They have center screen is on. Yeah, but this, I do not know whether this one, anything we can stop it.
Yeah, this stops it from going up. I don't know if it stops it.
Okay. The mute projector. Okay, that works. Okay, thank you. Okay, sorry, we just got a little interruption. So now let's start. I think it's kind of strange. Okay, so hopefully I think in the past I used this classroom quite a few times. I do not know this semester what things changed. Okay, so the first thing is about the CBOR Center. I just show you here. So before introducing this class, I first say in computer science department, we have one research section, or you can say research area, called Data and Information Systems. We just call it DIS, or you can say DAIS, Data and Information Systems. We have four research, like a focus. You can say one is database systems. I think Professor Chang and Professor Aditya Paramaswaran, they too are more on database systems. Of course, they're also working on data mining. For me, I'm mainly working on data mining. Of course, I also work a little on database systems, text information system, and networks. For text information system, the major professor who is working on is Professor Zhai, Professor Chen Zhai. And we have Professor Harry Sundaram is mainly working on networks. Of course, these five professors, they are really interdisciplinary in the sense they almost working on all these four, big data area. So it's a very important area. It's very hot outside, especially in industry and society. And we do have a very good group, very strong body of faculty working on it. Okay. So we offer quite a few courses. You probably can see is we offer like CS412, which actually will be taught by three professors, me, Professor Kevin Chang, and Professor Harry Sundaram. Okay. And for the graduate level course, which usually offer in the spring, I will be teaching CS512. That means if you learned CS412, you did well, you really want to take a more graduate level course on the research part, you can take CS512 in the spring. Okay. Then for database systems, we offer CS411, CS511, And for text information system, we have CS410 and CS510. Okay. Those are the courses in the very core area of big data. We do offer a seminar course on network as well, will be taught by Professor Harry Sundaram. Okay. Then remaining ones, you still will be able to take courses on machine learning in the field of AI and bioinformatics in the field of bio. Okay, so these are very closely related to big data and data science. Okay. For this course, I will be using my own textbook, which actually this textbook is probably the most popular used internationally. People are sending me this translation in Korean, in Chinese, in many other languages. Actually, I have lots of different language versions. Simply says they use this textbook most popularly in the U.S. and internationally. For example, this book, the foreword was written by Christos Faloukas because he told me CMU also using this course to teach data mining class. So that's why he would like to write the foreword for this book. Okay. I expect you probably got this book already. You can easily get it from Amazon or some places because there are lots of used books there in circulation. We are in the working on 4th edition, but likely 4th edition will be available in 2018 instead of 2016, okay, because we are still writing it. The class has a home page. If you click this button, you will be able to get into the home page. I think I probably will later. I think this is the dashboard. I probably cancel it. The home page actually gives you almost all the required information. You can get it, but the most important information is class schedule. There's a class page on every day. Okay, that one you want to put as a bookmark. Okay. And the course is in this classroom Tuesday and Thursday. We have 75 minutes for lecture time. The office hour is right after this class because right after this class, most of the students probably lunchtime, but you can come to my office, discuss anything. But you have some very short question, you can come right after this class or be staying here usually for 10 to 15 minutes. Okay. The lecture is recorded. So you, in principle, you do not have to come to class every day, but we do strongly encourage you to come because you can join the discussion. Watching video is a very different experience than staying in the classroom. You can raise interesting questions. Okay. But there's one thing is some students really like to see a large class because they want to have interaction with their classmates. Some students may prefer even to sit somewhere to watch video. Okay. So to that extent, we actually need to get some consensus whether we want to take the attendance sheet. That means every time we have a lecture, I pass the attendance sheet, you just sign up under your name. Okay. So I probably should get some consensus whether you like this practice or you do not like this practice. Okay. You like this practice means you sign up attendance sheet, maybe in the end of the class, for students who almost attend the majority of the class will get no penalty, no score taken off. That means if this one was 2% or 3% of your whole credit, you get these 2 or 3% as a class attendance. Okay. And if you miss, for example, we total have 11 or 12 weeks. If you miss 3 or 4 lectures, we start taking penalty. For example, if we miss all of them, you probably get if we say 2%, you probably get you will get a penalty of this 2%. You won't get the credit. Okay. So that's actually will decide by the class. That means if you like this idea, you really like have a pretty full classroom to join the discussion, you can raise hand, say, I vote for attendance. Otherwise, you say, I vote against. Okay. So we probably, you can prepare, think about this pros and cons. Of course, I encourage everyone. I just say whether you want this attendance sheet to sign or not. How many people vote for the attendance sheet and sign up? Okay? Seems we do not have that many people vote. How many people vote against? Okay, so that's fine. If you vote against, we will not distribute attendance sheet. That means it's not an obligation, but we encourage you to come. Okay. Of course, there's one additional probably side effect is if the student who register online only, they may have a chance to come to the class if the class is not full. Okay. So, but anyway, if you vote against it, we won't take the class attendance sheet. Okay. So we have, because we have a very large class, we have 4 TAs. Okay. These TAs are all graduate students in the data mining group. They are really good. They are very strong. So I think they can handle the class very well. I think the class is very full, so I only show them picture instead of asking them to show up. But you will be able to see them during the office hours. Okay. So for the office hour, our general philosophy is we plan, I just got a meeting with them, we plan to have every week, besides my 2 hours office hour, we'll set up 2 hours TA office hour in the regular way. Then every time before the homework due or program assignment due or midterm or final time, that particular week, okay, we are going to have double TA office hours. That means the TA normally will offer 2 hours, but any week the work is due, they will offer 4 hours. That likely that additional 2 hours will be somewhere closer to the due date, so you get help. Is that okay? Okay. So another thing is about a waiting list, because I saw a lot of people standing out at the back. For anybody who cannot register the class, you have a choice, is coming to this link. Okay. Sign up on the waiting list, not only your name, but you have to state good reason. Okay. If you do not have a good reason to say you have to attend, have to register in the fall, I strongly suggest you register in the spring instead of getting 2 big class in the fall. Okay. So for some student who did not attend today but still want to register, you can pass information to your friends. Say there's a waiting list, but you have to state very good reason. Otherwise, you may still not be able to get in. Okay. Then for the course grading requirement, that means what's the work you're going to do. Okay. So our plan, I discussed with TA, our plan is this. We will have 3 homework assignments and 2 programming assignments. 3 homework assignments, each will weight 5% of your grade. Okay. The 2 program assignments, each will weight 10% of the grade. Okay. Then we get a midterm weight 30%, and a final exam weight 35%. That's the general, our consensus. We used it in the past lectures. So I would open up for if anybody really wants to have some voice, you probably can express it, raise your hands. I know general voice, some people want to have a less weight on the exams. There's a lot of students. But the only thing we encourage to have these exams is for homeworks, program assignment, you can get help from your classmates. Or somebody may even do less work. Of course, it depends on whether we can catch some student, okay? Because it's very hard to know what exactly you're doing this homework, okay? But the exam, you have to do it on your own, okay? So usually this is probably a better way to check whether you really learned something, okay? So for the exam, we allow you to bring one cheat sheet. That means you can print or write in the normal, like an 8x11, the sheet in the double-sided way, one sheet, okay? Simply says, I do not force you to remember all the formulas, all the definitions. We mainly test your understanding of the course material. That means the exam is not like everything's closed. You have to memorize everything. Things you need to memorize, you can put in the cheat sheet. You can print it small. I do allow you to bring a magnifying glass, okay? If you really, say your eye cannot read very small font, okay? Is that grading scheme okay? How many people vote for it? Okay, come on. How many people vote for it? How many people have different views, if you want to express it? Okay. If you don't have different views, we basically set the scheme. I cannot change it dynamically because it's not fair. You did very well in the midterm. You say, I want to get more portion on midterm. Some people blow up and said, I want to count everything in the final. We cannot do that. Okay, so this is, final is computer graded. It's based on all your scores. The grading essentially is bell curve in the sense we do not say you pass 80%, you get an A, or pass 90%, get an A. We grade it based on your relative distribution in class. Okay. Since this is the fourth year, usually we will not grade very harshly. That means we do give a lot of A's, but not a half of the class. You clearly know that. Okay. So that means you still need to work hard in order to get a good grade. Another thing is some students register the fourth credit. Okay. We do have about a third student register fourth credit. The first thing I should say is I discussed with TA, we are going to do some project, not like you just write a small essay. Okay. If you find this project maybe is a little beyond your expectation, you can change from the fourth to the third credit. Okay. Of course, if you really want to change from third to fourth, it's also possible. But we do encourage you, if you do not want to take additional project credit, you just change to third credit instead of taking all fourth credit. Okay. You can discuss with me. If you really want to change from 4 to 3, you should discuss with me earlier because we cannot allow, but who first, drop the fourth, you probably cannot get into third. We probably have to do it a special way. We can change it. Okay. But later, if you really register the fourth credit, you may get an email from TA for some special meeting to discuss about the project. Okay. The final grading is for the people who register fourth credit, you'll be graded on the project. That project count as 25%. Then all the remaining will count as 75%. Okay, that's a grading scheme. You will be scaled down proportionally. Whether it will benefit you on the final grading or it hurt you, we do not know. It really depends on how well you do that project. Okay. So that's about the fourth credit. Then another thing very important is you should sign on Piazza. Okay. The Piazza means it's a discussion forum. I assume you all know it. Okay. If you get any question, you need help, you need to, so for example, especially for the program assignment or some assignment, you encounter unexpected difficulty. Of course, you can see TA, but sometimes maybe you just post a help. On Piazza, somebody may give you some easy hint or something. But remember, for all these assignments, you should do it independently. But discussion is allowed. Simply says you really get confused, you need some explanation of this point. You can post on the PS and somebody may help you. But you're not allowed to post the answer, okay, of the homeworks. If you do that, you get a penalty or disciplined. Okay. So we know the discipline in the department is quite rigorous. You don't want to cross the line. Okay. That means you should not say, I need help on this program, I just cannot do it. Somebody can come to my office or something. That's not good. Okay. And you say, oh, I know the answer already. I post the answer on the web, on the Piazza. That's also, we should be disciplined. Okay. And for your homework exam, all the scores, you can check on Compass. Okay. I assume you also know how to sign it on. Okay. That means once we finish grading, we will post your scores on Compass. You can read it. You very likely you will also see the class distribution. Okay. So that's about the lecture. Okay. Before I talk anything on the technical. So any questions you want to raise before I go to the introduction to data mining? Any questions? Okay. If there's no question, we still have more than half of the class time. We are going to discuss the first chapter, is general introduction to data mining. That means why we want to do data mining and what is data mining. Actually, I believe I probably do not even need to lecture on this. Everybody knows we got lots of data. Okay? The data is exploding, anywhere. For example, for people studying biology, you probably say the biology, 1 year generated data, probably you count the last, 20 centuries, probably would say, this is more than the last 20 centuries data, which is very true. Okay? Anywhere you get this. Okay? So for the large data, not only you want to get data, the most important thing is you want to turn data into knowledge. So there are some famous sayings say we are drowning in data but starving for knowledge, which is to some extent in the big data or data science area, why there are so many companies want to hire data scientists. Just because they got lots of data, they want to turn data into knowledge, into useful things. Okay. So that one, I probably do not need to give you any example. You just go to Google or you go to any internet-based company. They say they got lots of data. They got, terabytes data. But what is data mining? The data mining essentially is mining knowledge from data. Actually, early days, the people actually got into the term called knowledge discovery from data. They coined the term called KDD. KDD means knowledge discovery from data. The big conference, I just came back last week, was KDD Conference 2016. Okay, that's the knowledge discovery from data. They call it knowledge discovery and data mining. Okay. But the regulators say data mining actually is some kind of misnomer. Even everybody knows what is data mining. Because you do gold mining, right? You go down to some beach or some place in the mountain, like California early days. They mine gold, but gold mining is not because they got too much gold, right? They got too little gold, they got lots of sand. They mine gold from the sand, but they never call sand mining, right? They call gold mining. So we call it data mining. Actually, in principle, it should be nugget mining or, knowledge mining. You mine knowledge from the huge amount of data. But people are thinking data mining is a nice term in the sense, actually, you know what you really want to do. It's not like a coal mining, gold mining. You mine for gold, mine for coal. But we do data mining. So we got lots of data. We're mining knowledge from data. Okay. That's why data mining actually is even more popular than knowledge mining. People just take it. Okay. But there are many other terms you probably can see. Even some people may be thinking like a business intelligence. Actually, they do a lot of data mining. Of course, they do other things as well. Okay. But since data mining is very fashionable, some people are thinking everything is data mining, as long as you touch data. Actually, it's not. For example, you do query processing. Like you search the web, you search the database, you give a query, you get the results out. That's not data mining. That's a retrieval. We call it information retrieval, data retrieval, right? That's not data mining. You go to database systems, the majority thing they are going to do is they manage data, they retrieve data, they do query processing, right? That's different from data mining. That's why it's two different courses. You do information retrieval, you go to the web, you put a query, they give you the answers. Of course, if they want to give you in a nice way, for example, they want to rank the web pages, they have to do some data mining. But essentially, you give a query, I get the results out, it's search. Okay, we call web search. But of course, web mining is somewhat related. Okay. Another thing is you get lots of rules, so you get derive new data. For example, you say, I want to get an ancestor. The ancestor rule is the parents and parents and parents. Then you get all the parents' parents, you get ancestor. That's not data mining. That's the deduction. Okay, you give the rules. I already know your parent relationship. I give you all the answers. That's inference, deduction. It's not induction. Induction means you discover something from data. So that's data mining. The data mining, a lot of people draw this picture. The picture actually says you start with big data in database. Actually, it can be anywhere on the web. Okay, you know, in some kind of folders. And with this, usually you need to do data integration and data cleaning. Data integration means you get lots of different sources. You want to integrate them together. Okay. Data cleaning means the data itself is very dirty or is not relevant. So you need to clean the data. Of course, clean data, you may use data mining tools to clean it as well. After that, you may put the data into related data warehouse or something. The data warehouse, we're going to discuss it as well, right? How to integrate data to warehouse. Then you say, I want to mine this portion. Then from the data warehouse, you may get a task relevant data. It means the data you're really interested in. Okay. Then you can kick in the data mining tools. Like you can do clustering, you can do classification, you can do pattern discovery. You may get a patterns. Once you get a pattern, you may evaluate the pattern whether this is good enough for you or you want to give in different parameters or different data mining queries. And finally, you may get knowledge you need. So that's the whole process. We call this one is a knowledge discovery process. Some people call this as a KDD process. Okay. For example, you think about it on the web. If you work in Google, okay, what do the people do? The people got all the different web pages. They may do data cleaning. That means you get rid of something they think is not relevant to their ranking or searching queries or something. They integrate data from multiple sources. They may warehouse the data. They may build some kind of a knowledge graph or some kind of repository. They may construct data cubes. They may do data selection for mining. Then they do the real mining. Then they present the mining results. They may get a knowledge even stored in some knowledge base. Okay. So that's the whole process. Okay. In Google, they do almost every sector of this, right? So I think you go to other companies, for example, Walmart, or you go to stock companies. You go to many companies. They almost doing the similar things, but on different kinds of data. So from the business intelligence point of view, they may say you got a data which is, very diverse sources. You may have web documents, you have experiments, you have database systems, or some stored in the files. Okay. Then you may integrate this data to do some pre-processing, to do warehousing. Then you may kick in some kind of data exploration tools. For example, you can do summary. do querying, do reporting, but then you may do data mining, we call information discovery. Then you can visualize the patterns, and finally you can make decisions. So that whole process, some people call decision support systems. The decision support, you need the data, you need the analysis, finally you can make decisions. So that's the business intelligence also doing data mining. You can see that's a typical process. Then we get into machine learning or statistical analysis. They may have a little different view from the big data view, but they probably say, I don't care the data is very big or somewhat smaller, but I need to analyze data. What they do, okay, their view on data mining, which is similar, but it's a little different, is you got to input data, big or small, okay? I first do some kind of processing. Processing may be integration, may be normalization, may select some features, may do dimensionality reduction. Then anyway, I need to pre-process the data. Then I kick in data mining. Data mining could be pattern discovery, could be some machine learning modules like classification. You can do clustering, you can do outlier analysis. There are many, many functions on data mining. And after data mining, you still need some post-processing. That means you may evaluate the patterns, select the patterns, interpret the patterns, or visualize the patterns. And finally, people will see the patterns, information, knowledge, anything you think is valuable to your business. Okay. So that's the view. Whatever the view, essentially, is different people have different choices. That's not to say which particular view is the best view. It's just based on different data, different processes. So they do not have some very major difference, you probably can see, right? But data mining somewhat is different from data exploration, because data mining usually want to go deeper, okay? The data exploration usually is you do data warehousing, you do data cube, you do reporting. You see the data in different pie charts, bar charts, you may see some curves. So that usually is doing things on data exploration. That means you try to see the general view or something on the data. But data mining usually go deeper. Okay, you really want to find the deeper patterns. You need to kick in more sophisticated algorithms. Okay, so they are related, but they are not identical. Okay. Now I'm going to view the data mining in multi-dimensional space. Multi-dimension means I want to see one dimension is data. What kind of data you're going to use? Okay. Another dimension is knowledge. What kind of knowledge we're going to mine? Okay. The third one is what kind of techniques, whether you are focusing on statistic ones or like a data warehouse database, data intensive ones, or something more on the pattern recognition or deep learning or using visualization, using high performance computing. They have lots of different techniques doing data mining. So we can look at it from technical angle. The other people may look from the application angle. For example, if you are doing retail in Walmart, your data mining may be very different from Google, their web search service company. But you go to banking, they may want to have fraudulent analysis. But you go to biodata, they probably want something very different. Right? Then the same thing you do, for example, security. Okay? You do like you try to find potential terrorist attacks from data. So that needs different focus on different mining functions. So you probably can see from every application you may develop some kind of research into this one. So to that extent, you think about this. You get so many different kinds of data, so many different technologies you can develop. Data mining, even from the research point of view, is a very rich domain. It may contain thousands of PhDs. So if you work on research, right? Then I probably want to give you every view in a little more detail, like what kind of data can be mined, what kind of pattern can be mined, what kind of technique can be used, or what kind of application we want to explore. So you can see these 4 dimensions. For each dimension, I'm going to discuss a little detail. Okay. The first thing is data. the data could be very, very different. So the data, the first thing is some people thinking data mainly is stored in the databases. Even in databases, there could be very different databases. For example, the typical one you see like a registration system, banking system, they use relational databases. Okay. Some, they want to analyze data, they build large data warehouses, integrated multiple databases in the long history. They try to do the drilling, to do the multi-dimensional analysis. There are transaction databases, like a marketing, like a Walmart may have a very long transaction. They want to study customer shopping behaviors. Okay. The transaction database. There are also a lot of other kind of databases, like object relational. They are more flexible than a relation, have object views. Some heterogeneous database, you want to integrate them. Some old legacy databases, you want to mine the old data to compare with the current ones. But there are many other kinds of data. For example, data streams. You probably see there are lots of sensors. You know, they get the real time, you know, like traffic. They want to analyze them. Like Google, you go to Seattle or some places, they may have an online, you know, say which road is, you know, is very jammed. The other road you may want to go. How they get it? They get it in the real time with lots of video cameras. They actually can sense the traffic. Or nowadays, there are lots of cars themselves as sensors. The car movements, they can sense whether the traffic is smooth or not. Okay. There are lots of time series data. Like a biological, they have a protein sequences, gene sequences they want to analyze. There are structured data, like graphs, social networks, information networks, communication networks. Those actually give you lots of data to analyze. Spatial temporal data. Like we said, the traffic, it could be spatial. The map, you may have multiple layers, you want to overlay them. We have multimedia data, like videos, like in YouTube. We have text databases. Text data is tremendous. The web pages, majority is text. And plus, I remember I went to Boeing. Boeing said how much text they have. Just Boeing, one model manual. Okay, they say because they printed many languages on many different parts, they have millions of parts for one, you know, airplane. They say if you look at the documents, you print them, you were, you know, part of this from the Earth to the moon, you know, multiple rounds. That's just Boeing one model airplane. Just think of how much printed documents. Of course, they are not even printed out. They are in the e-version, right? The web contains a huge amount of data. You probably see the data is really very rich. Even you want to do data mining, you sit, you know, right in front of your computer, you can download gigabytes, terabytes data easily, right? So then we see what kind of pattern, what kind of knowledge we want to mine. Actually, there are many different kinds. The first one we are going to study is generalization. That means you got lots of information, you clean them, integrate them, you finally want to put them in a way you can easily summarize them. Okay? To summarize them, the most powerful way is data cube technology. That means you can summarize the data in a multi-dimensional way. You can easily see the pictures on many different dimensions. Okay? That one we are going to study is data cube OLAP. It's online analytical processing. So that's about a generalization. That means you want to summarize data, generalize them in a multi-dimensional way. People can easily view the data in a very high or low summaries. Okay. Another one is pattern discovery. Pattern discovery means you want to find particular patterns, something closely linked together. For example, the typical one, it could be a little joke. Some people early days, they do data mining in some, you know, like U.S. stores. They say they found people in the night, they buy beer, like they buy diaper, likely they're going to buy beer. So they get this kind of a beer diaper association. Of course, some people even give interpretations that, you know, usually at night, the man going out to buy diaper, they really want to get beer as well. So that's why you get this rule, right? But there are many other very useful patterns and rules. We're going to learn quite a lot. We call this is pattern discovery. Okay. Actually, I myself is teaching a Coursera course. The new version will be available in the late August, actually next Monday. It's called Pattern Discovery in Data Mining. Okay. If you are interested, you can sign up and watch the video, which is part of our course as well, right? Then watch video sometimes is more enjoyable. Then classification. Classification, some people call predictive modeling. That means you got a different, you can see there are some green and some red, different things. For example, okay, just thinking about the doctor, some patient, they want to judge whether this patient, they got some sample, they get some tissue, they want to check whether the patient got cancer or not, okay? So what they do is they take this tissue, they go to some kind of classification model, based on different measure, then they finally determine whether this tissue is cancerous or is benign, okay? This is critically important. You want to get a high accuracy, but you don't want to miss any potential cases, because you miss it, the cancer grow to the stage it cannot be controlled, the people may die, right? So this is a very critical. You do data mining, you do the right one, okay? But of course, you may sound false alarm. If you sound too many, people may not trust you, right? So that means you really want to do high accuracy classification. For example, for climate, weather prediction, they need a classification. For predict the car, how far they can go, they also need a classification. So there are so many classification methods we are going to learn. And of course, in this lecture, we will only give you the very high level, it's like an overview rather than give you very, very deep analytical method. If you want to know very deep analytical method, you may need to even take, for example, a machine learning class. Right? They probably can give you, because that's a whole class, it's just on classification. But here we take classification as part of it. Okay? And cluster analysis. Cluster analysis, some people call unsupervised learning. Okay? The classification is supervised in the sense they give you some sample, they train you. They say, oh, this kind of tissue is cancerous, this kind of tissue is not. They give you some, it's like a teacher first teach you how you should judge. Then you contain model. Cluster means there's no teacher. You just got the data. You judge whether the data should be partitioned into different groups. Okay. Just thinking about it, if you fly into Champaign, okay, before you arrive, you actually fly over the city. You say, oh, that part is a field. That part is a university. That part is residence. How do you know it? Is there anybody telling you or train you? Because I don't need training. Okay, those cornfields green is so obvious, right? So that means you based on the features of the data. Based on the image features, you know this is cornfield, this is the residence, and that part is university. You can see it, right? So that means you, based on the feature of the data, their distance, you can automatically partition them into different groups. Those are cluster analysis. Okay. Then outlier analysis. I put a lot of apples on the picture. You probably can see why I say this is outlier, because there's only one red, all the others green, right? So you can see that's outlier. Okay. And there are many other kinds of outliers. For example, you can do regression analysis. Some kind of regression, you can see those points is outside. Or you can do correlation analysis. You also find there's something far away from your correlation analysis. You can also say those are the outliers. Okay, so we are going to, if we have time, we're going to discuss this as well. Okay, but there are more things, maybe even beyond this class. You can go to CS 512, or you can go to some Coursera courses. You can learn more. One thing is about a sequence trend and evolution analysis. In this class, we are going to learn sequential pattern mining. But for time series deviation analysis, I probably suggest you go to a class like a signal processing, those kind of class. They probably will discuss more on the regression time series analysis. There are many other things. For example, for biological sequence analysis, I suggest you take any course in bioinformatics. Okay, so there are many other things to learn, but data mining definitely covered this part. Okay, and data mining even covered structure and network analysis. That means you find graphs like a chemical compounds. You will say these chemicals are very similar. Okay, you do some graph similarity search and mining, and you may, analyze social networks, information networks, and the web. Those are also data mining. You go to Google, they do a lot of data mining, right? And then, if you mine the patterns, the very important thing is you want to evaluate them, judge them, to see whether they are particularly interesting. That means you want to communicate your finding to other people they think is valuable. So how to judge the pattern is valuable? In every mining module, for example, classification, our analysis, we are going to give you some measures. Say, this measure likely you want to use because you will disclose something interesting. Okay. So, for example, interesting may involve coverage. That means how much your pattern may cover. Typicality versus novelty, whether it's typical, whether it's novel, whether it's just a noise, okay, or whether your pattern is accurate, your model is accurate, you really can predict whether it's really timely or it's old, it's outdated already. So there are lots of things you want to take care of. Okay. Then, from the methodology point of view, actually, data mining is integration of multiple technology. Okay, that means why we take data mining as a course, just because there are so many techniques we can use them at our preference, at our will. We want to dig out the important things from data. That means we are not stick on a particular technique. But a very important thing is machine learning is very important because we are going to discuss a lot of classification technique, essentially originally from machine learning, some from statistics, some from pattern recognition. Okay. And we have a lot of particular technique just available in data mining. For example, a lot of pattern discovery is just discovered in data mining community. But there are many things related. For example, algorithms. You want to analyze whether your mining one is efficient, is almost linear, or is so expensive you just cannot use it in a large scale. Okay. We're going to discuss algorithms, complexity. We want to visualize data. For some complex algorithm, we want to do high-performance parallel processing or Hadoop or something. We're not going to cover this, but these technology will be very useful for data mining as well. Okay. Database technology, you want to reduce disk access, you want to optimize the processing. The database technology is also very important. You can see the data mining actually are from many, many domains. For example, you want to study web, you probably want to study web science. You study the spatial, you may need to even talk to people working on geography. Okay? Not to say you work on bio, definitely you need bio knowledge. So that's the reason we say data mining actually is a confluence of multiple disciplines. Of course, our focus is more on the analytical functions. That's our focus. But you should know, actually, many, many different disciplines may contribute to data mining. And in reverse, your data mining may be applied to many other disciplines. Okay. Then we look at applications. Applications, I think, probably the easiest one I can address because data mining is very useful. For example, for web page, I actually got a lot of students currently working in Google. Last week, we got in San Francisco KDD conference. I have lots of students, current one and the previous graduate one. They want to get together, have a celebration, get a dinner party. We counted it. We do not allow anybody not directly supervised by me to join. That means their spouse or they are, some other, students just taking my course, I actually do not invite them. But we got 30 people. They, probably 28 PhDs and 2 very brilliant masters they join. They are, there are lots of professors, lots of, the company's major players. Okay, they are very successful. Okay, in all those companies, Google, Twitter, Facebook, LinkedIn, all things you can think, they actually all join. That's analyze web. They need data mining. Okay, and you want to recommend something like LinkedIn. They want to recommend you jobs. Okay, or they will recommend you to some companies. They need a recommendation system. They need a lot of data mining. Okay, shopping basket analysis. Any internet company, like I actually have a student who came from eBay, especially on the PayPal. They need a lot of data analysis to decide, on the eBay how to do this. Biological medical analysis needs data mining. Recently, UIC got a big center on the BD2K. What is BD2K center? BD means big data. 2K means to knowledge. Okay, that's a NIH support BD2K project, mining biological data. Okay. Software engineering. If you take Professor Tao Xie's course on software engineering, people will tell you is doing a lot of data mining. A lot of things, data mining algorithm we developed, they are reading it. To my surprise, he is a major software engineering researcher. At a KDD conference, I actually met him. I said, why you come? He said, everybody wants to learn data mining. Okay. And text analysis, like Professor Zhai is going to teach you text information systems. We do a lot of text mining as well. Later, especially if you go to my graduate level course, you will see the text that you need to develop a lot of data mining methods to handle it. Okay. Social information network analysis is very important. I got one PhD also met in the last week. She currently is a professor in UCLA. Okay. She got a PhD here. She got a 2013 KDD dissertation award. What is her PhD topic? Mining heterogeneous information networks. That means she did 5 years PhD just on the networks mining and got lots of papers, very interesting ones. And there are so many things, but essentially data mining has 2 major applications you can consider. One is built-in function. That means the user may not even know they are doing data mining. For example, you search Google, you click something. Google may already mine a lot of things finally to support you to rank the first page, to your best benefit. For example, you click my name, you type my name, you immediately find my homepage on the very top. Okay. How they do it? They do it automatically. Okay. They actually got maybe 20,000 pages. They know the first 10 they put on the first page. It's the most important one. But they do not do it by human, They got millions of requests per second. Right? They do it automatically. How to do it? Data mining. They mine this, they know which one is more important. Okay. So you can see these are built-in, we call invisible data mining. You do not know it, they did it. Okay. But there are many, many data mining tools. It's people, analysts. They can use the SAS, you can use Microsoft SQL Server, you can use Oracle data mining tools. There are so many data mining systems and tools, on the market already. They use those tools. That means those are data miners. They work for a company, they work for something, they do it. Okay. You can see there are 2 kinds of people. One is the invisible ones. They just support it behind the scene. You even do not know they are doing it. Right. So then, why we studied data mining? The first important thing is you need to know the basic skills. When you go out, you want to analyze data, you have learned quite a lot, then you can really do the real thing. Okay. Another important thing is data mining has lots of open problems. That means we just got into the computer in the last 50 years for human beings, right? And we got data generated in the big data in the last 10 years, maybe. You can think about this. I still remember when I was teaching in Canada 15 years ago, we invited Jim Gray, who was a Turing Award winner. Okay, he was doing database. He brought a disk which is half of this size, okay, at that time, and he just showed you, guess what's the capacity of the disk, okay, that time. And people say, 200 megabytes, or some people say 500 megabytes. He just say, you can hardly imagine, this one is 2 gig. Everybody say, wow, 2 gigabytes. You probably, now if I give you a hard drive, say 2 gigabytes, you probably throw it into a garbage can, right? So you probably can see the technology change, okay? And the technology change means you actually have a capacity to handle terabytes data even on your laptop, right? That actually changed the data mining game as well. Okay, when I invited him, he showed this two gigabytes data. At that time, we were already doing data mining, but that data probably is small. Okay, now you're really doing terabytes data mining. Okay. But the technology is there, but the software, the real data mining, problems, there are lots of things cannot be solved so quickly. There are lots of open problems. For example, you want to mine a lot of different new technology, new knowledge. You want to mine in a multi-dimensional space. You want to use different, tricks. There are lots of things on mining technology we need to develop. The user part, you want the user to be very flexible, don't need much education, but they can mine data. Okay. Then they can do, efficiency, to handle lots of different types of data. There are also lots of society issues. For example, if you want to mine data, some people say, I don't want you to mine because that's my personal data, right? So there are privacy problems a lot related to data mining, where we should mine this data or we should not touch it. Okay. Actually, people develop technology, say, I mine this data, I guarantee I will not touch anybody's privacy. They call privacy preserving data mining. There are, active research on this. So finally, I probably give you a little history on data mining before the next lecture. We're going to give you the real, going down to the data in detail. The data mining, of course, if you trace the history on data analysis, you probably can trace 2,000 years. Okay, people actually. You probably know statistics. They start the statistics. The name is something related to state. That means once you set up a state, you want to get some information, get some general summary, then that's the time they came statistics. You can trace a history when the people still carve something on the bamboo or something. That time the people are doing a little number counting. Right? But for computer science, really serious work on data mining, actually started in 1989. Okay, that's a conference associated with International Joint Conference on AI, called ICHCON. They have a workshop called Knowledge Discovery in Databases. Okay. That's the first time they got people together, try to say how to develop a discipline which can do knowledge discovery from data. But quickly, just a few years later, they found this workshop is too small. Because I actually attended this first workshop. That time there were about 20 people. Okay? That's a very small workshop. People spend a day discussing it. But by 1995, there are hundreds of people that want to get into this workshop. The workshop is too small. They set up the first international conference. To their own surprise, this first international conference was co-located with ICHCON. With a very big conference. They have about 500 or 600 people attending. Then this first data mining conference, KDD 2095, already go to over 500 people. That means they co-located with a bigger conference. They actually outnumber the bigger conference as the first one. Okay. Then I actually serve as the program committee chair for the second one, is the KDD 1996. It's already much bigger. This year, I just came back from the 2016 conference in San Francisco. they themselves are surprised with so many people joining. They actually raise the registration fee is pretty high. They got 2,800 people, 2,800 people attending the conference. So each room, actually, you can think about it. They have 5 parallel sessions. You divide them. Each room is bigger than this, is filled up with people, right? So that's a very, very flourishing field. They call for all the data science, this data mining conference so far is the largest one. Okay. Besides that, there are many conferences. For example, besides KDD, they have like PAKDD, Pacific Asia KDD Conference. PKDD is in Europeans. They call Principles of KDD. So that's 1997. SIAM Data Mining Conference is started by SIAM, which is a scientific computing community, set up this. And this IEEE, because this KDD is ACM conference. IEEE set up a conference also in 2001 called International Conference on Data Mining. Okay. Then web, besides they have Worldwide Web Conference, they found they specific need a data mining conference. They set up Web Search and Data Mining Conference starting in 2008. Now it's also a very big conference. There are many journals dedicated to data mining. For example, ACM Transactions on Knowledge Discovery from Data set up this journal, ACM journal, in 2007. Okay. So that's now it's still growing very quickly. This community grows bigger and bigger. Okay. So you probably see I list those conferences, simply says in the future you want to find the papers. Every year you will find lots of conferences that publish very good papers. There are many journals as well. Okay. So the best way now to find research papers is you can go to those conference proceedings journals, but there are many other conference journals. For example, database systems. They publish lots of data mining papers. AI and machine learning conference, they also publish lots of papers on data mining. Web, okay, statistics, visualization. There are so many different fields they touch or they contribute to the research on data mining. Okay. So finally, I should say is data mining is a very rich field. It's a young field, but already quite big community because people think it's very useful. Okay. So for this class, the textbook is my own book, and which is also very popularly used. You go to many universities, use the same book. But on the other hand, there are several other data mining textbooks I marked as red. One is the Penning 10. This is Michigan State University and University of Minnesota. They have a joint book called Introduction to Data Mining. They have many good examples. You can do the reference. Another one is Mohammad Zaki. He has a book published in 2014, give you some very clear, explanation on some theoretical aspects. Another one is IBM Sharagawa. He has a data mining D textbook published in 2015. I put all these red ones into the university reserve in the sense, if you want to read the other books, you go to the Granger Library, you will be able to find those books. Plus, there are many machine learning pattern classification books you may like to read. Okay. So, finally, I should say, for people who could not get registration and you want to discuss with me, you can come right after this lecture. Okay, thank you. Yes.